Welcome once again. Here is your friend Israeli Mass Concept. In this tutorial, I will teach you how to calculate the median of a given set of data, which involves interval. Remember that any set of data that involve interval, we call it a grouped data. And in my previous video, I already taught you how to calculate for the median of a given set of data, which does not involve interval. That means that one is for ungrouped data. But in the course of this video, I shall also teach you how to calculate for the median of a given set of data which contains interval. That is for grouped data. Do well to subscribe to my YouTube channel if this is your first time of viewing, and at the same time hit the notification bell right there so that whenever I drop a new math content, you would be notified. I have a question on the board, and this question is sourced from WAEC, and that is the year 1996. And that is question number 3C. The question says, the table below shows the marks obtained by 40 pupils in a mathematics test. And the marks are 0 to 9, 10 to 19, so they are grouped. And the second row is about the number of pupils, which are 4, 5, 6, 12, 8, and 5. Automatically, the number of pupils are just the frequencies, that is the F, the frequencies. Why the marks is just the intervals, that is the I, the intervals. All right, we are asked to calculate the median of the distribution. So we are asked to calculate the median of this distribution in this table. What do we do? First thing first, we shall state the formula for calculating the median of a grouped data. And the formula is giving us the median equal to L sub 1 plus, in brackets, small n over 2 minus CF sub B, and that is all over F sub M, then multiplied by C. Let me first of all explain the individual parameters contained in this formula. Remember that this formula, you have to put it in your heart so that whenever you are asked to calculate for the median of a grouped data, you can easily put forth the formula. The L1 or L sub 1 simply stands for the lower class boundary. The lower class boundary of the median class. Then the N stands for the total frequency. The total frequency. Then the CF sub B. The CF sub B simply stands for the cumulative frequency before the median class. Before the median class. Then the F sub M. The F sub M simply stands for the frequency of the median class. Then lastly, our C, which is our class size. So we have it as our class size. To record this formula, it is very simple to do. The L sub 1 simply means the lower class boundary of the median class. Then the N stands for the total frequency. We are still going to apply all these formulas so that you understand this concept very well. Then the CF sub B simply means the C is for the cumulative, the F is for the frequency, the small b is before the median class. Then the F sub M stands for the frequency of the M, which is the median class. Then the C stands for our class size. All right, let's go forward to calculate for the median of this distribution. First thing first, you draw your first horizontal line and then cross it with your vertical line. On the first column, we shall have our marks. that is marks. Then on the second column, we shall have our class boundary. Our class boundary. Remember, one of our formula parameters says lower class boundary. So there is need for us to have our class boundary. And also there is need for us to put the marks we are given as the range or the interval. Okay, then after the class boundary, we shall have what we call our frequency, which is our F. Then after our frequency, remember the reason for this frequency is because we have frequency as one of the parameters in the formula. Then after the frequency, we have what we call cumulative frequency. Already we have CFB, which is cumulative frequency before the median class. Therefore, there is need for us to have our cumulative frequency. Let's start to enter the values for the mark. The marks we have here are 0 to 9. So we have the first one as 0 to 9, followed by 10 to 19, followed by 20 to 29, followed by 30 to 39, followed by 40 to 49, followed by 50 to 59. I think that is the last one. All right, having completed for the first column, let's also fill in the second column. And the second column is about the class boundary. So how do we fill in the class boundaries of these marks? It is very simple to do. What do? We shall be subtracting 0.5 from every values we have here. That is the values we have here: 0, 10, 20, 30, 40, and 50. So we shall be subtracting 0.5, so minus 0.5 from all these values here. Then for all the values 9, 19, 29, 39, 49, and 59, we shall be adding 0.5. Remember, we shall subtract 0.5 from all the values we have in this lower class mark, but we shall not subtract it from 0. The reason is because if we subtract 0.5 from 0, automatically it will give us equal to negative 0.5. And there is no negative range here. See, it will deviate from the range we have in these marks. Hence, we don't need to subtract 0.5 from 0. So we leave 0 like that. Then that is adding 0.5 to 9, we shall have 9.5. Then also for 10, when we subtract 0.5 from 10, that means 10 minus 0.5, which will give us 9.5. So here we have 9.5, and that is to, when we add 0.5 to 19, we shall have 19.5. Then when we subtract 0.5 from 20, we shall have 19.5, and that is to, when we add 0.5 to 29, we shall have 29.5. The same thing follows suit. Remember the way or the sequence this thing goes. Here we have 9.5, and at the diagonal we still have 9.5. Here we have 19.5. At the diagonal we have 19.5. So automatically here we shall have 29.5 at the diagonal, and that is to, when we add 0.5 to 39, we shall have 39.5. So at the diagonal we have another 39.5, and that is to, then when we add 0.5 to 49, we shall have 49.5. So at the diagonal we shall have 49.5. So when we add 0.5 to 59, we shall have 59.5. All right. Then coming to the frequency side, the frequency are just the number of pupils, which is our F, and that is 4, 5, 6. So we have 4, we have 5, then we have 6, we have 12, we have 8, and we have 5. Then coming to the cumulative frequency column, how do we find it? Very simple. We shall first put the value of 4 of our frequency. Then we shall add this 4 to the 5 here to give us 9. Then we shall add this 9 to this 6 here to give us 15. Then we shall add this 15 to this 12 here to give us 27. Then we shall add this 27 to this 8 here to give us 35. Then we shall add this 35 to this 5 here to give us 40. All right, having completed our table, let's go ahead to find the median of this given set of data. And to find the median of this given set of data, the first thing to do is to find our n over 2. And remember, our n, we stated it as the total frequency. So let's sum up all the frequencies we have here. 4 plus 5 plus 6 plus 12 plus 8 plus 5 will give us total of 40. If you don't want to struggle in summing it, just take the total cumulative frequency we have here, the last one, which is 40, and that is automatically the total frequency we have. And even though you sum with your calculator all the values for your frequency, it is still going to tend to 40. So our n is 40. So we have 40 over 2. And 14 divided by 2 will give us 20. So this 20 is the 20th median position. The 20th median position. So we shall come to the point or to the column of the frequency and begin to sum up our frequencies to know where this 20 lies on this frequency column. So let's begin to sum up. 4 plus 5 will give us 9, and 9 is not up to 20. Then that 9 plus 6 will give us 15, and 15 is not up to 20. Then that 15 plus 12 will give us 27, and obviously 27 lies here, and 27 is up to 20. So automatically, in this given point, everything we have in this given place or line is called our median class. That is very simple. Everything we have in this given line is called our median class, because the value of 20, that is the 20th median position, lies on this line. That is the implication of it. So having found our median class, which is this line, let's go ahead to find our median. And to find our median, we have that median is equal to L1. What is L1? L1 means the lower class boundary of the median class. So automatically, this place I've circled is our median class. So this is our median class. So we shall find the lower class boundary of the median class. So coming to the class boundary side, every values we have this side is called the upper class boundary. Then every values we have here is called the lower class boundary. But we are concerned with the lower class boundary of the median class. And this is the median class, and this is the class boundary, and this is the lower class boundary of the median class, which is 29.5. So we have 29.5. Remember, the value here is the upper class boundary of the median class, while the value here is the lower class boundary of the median class, which is what we are concerned with, and that is 29.5 plus, in brackets, our n over 2 is automatically 40 over 2, which we got to be 20. So we have 20, then minus, we have the cumulative frequency before the median class. Remember, this is still the median class, and here is the cumulative frequency of the median class, which is 27. But before the median class is 15. After the median class is 35. I repeat, this is the cumulative frequency of the median class, which is 27. But we are concerned with the cumulative frequency before the median class. So before is the value 15. So we shall add 15 here. And that is all over the frequency of the median class. This is the median class. Remember, we circled it already. And the frequency of the median class is 12. So we have 12. We close our brackets. Then multiplied by, what is our class size? Our class size is very simple. We shall say 20 minus 10, which will give us 10. So 10 is our class size. If you don't say it from this point, you can say it from this end. 29 minus 19 will still give us 10. Or you can say 39 minus 29, it will still give us 10. Or you can say 30 minus 20, it will still give us 10. So we have 10. So let's solve further. Our median is equal to, we have 29.5, then plus, in brackets, remember 20 minus 15 will give us 5. Then we have 5 over 12. Then multiplied by, we have 10. So this is equal to 29.5 plus, remember by the rule of BODMAS, your multiplication will come first before you add up. So let's multiply this in between fraction and value first before we add up whatever we get from it to this 29.5. So we have 5 multiplied by 10. Remember 10 is same thing as 10 over 1. Such that 5 multiplied by 10 will give us 50. And that is 50 all over 12 multiplied by 1 will still give us 12. And here we have 29.5 plus. So with our calculator, when we punch 50 divided by 12, 50 divided by 12, we have 4.17 approximately. So 4.17 approximately to 2 decimal place. And that is equal to, so our median is equal to, when we add 29.5, 29.5, when we add it up with 4.17, we have 33.67. So automatically the median of this given set of data, which we computed on the table, is equal to 33.67. This is basically how to calculate for the median of a given set of data, which involves interval. Thank you for viewing. Thank you for watching. If you found this video useful, remember to reshare this video, and at the same time subscribe to my YouTube channel and hit the notification bell there so that whenever I drop a new math content, you would be notified. Thank you and see you next time. Goodbye.